Yes, sir.
Now, so what I can do is multiply square both the sides. So I'll get sine square plus
Ah.
1, and here I have a cos
Mm.
square, and then 1 minus cos square give me
Mm.
sine.
Okay, sir.
Which will give me this one. Okay, so square both the sides. This will give me 1. So 1 minus cos square. Just
Okay, sir.
2 root 2, right? So 2 cos square, so I'll take 1 cos square here.
Mm.
That'll give me sine square.
Mm. So it would be cos square minus sine square.
2 cos square, yeah. Cos square minus sine square. Okay.
Ah.
Okay, so these two just taken to this side. So cos square will make it cos square minus
Mm.
sine square. Okay,
Mm.
this thing. Cos square
Mm.
minus sine square to 2 sine theta. These two will take it here. And cos square minus
Okay,
sine
sir.
square can be written as cos plus a plus b into a minus b.
Okay, sir.
What we need is a minus b.
Mm. Mm.
A minus b is this one.
Okay.
A cos theta.
Mm.
Cos theta plus sine theta is root 2 cos. That's where we started, no?
Mm.
We'll use that itself.
Ah.
Okay. This one, this one.
Mm.
See, here I got 1 plus tan theta is root 2, right? So similarly, if I do here,
Mm.
I'll get divide by sine, I'll get uh, cot theta, which is 1 by tan theta minus 1 equal to
Mm.
root 2.
Mm.
Okay, so these two should be equivalent.
Mm.
That's correct. Divide by sine, I'll get 1 by tan minus 1 equal to root 2.
Mm.
1 minus tan theta by tan theta. So 1 minus tan theta by tan theta equal to root 2. This is the other proof. Okay, this is given. This is the first
Mm.
one. Okay, so this is same as 1 multiplied and divide by 1 plus tan theta. 1 plus tan. So this is 1 minus tan square. 1 minus tan square is
1 minus tan square is
1 plus tan square is
uh,
secant square.
ah
Okay, so
1 minus tan square
then
is
I have
then
square this one itself. I don't have to do.
mm.
So squaring that, I'll get 1 plus tan square plus 2
Mm.
tan equal to 2.
Mm.
1 plus tan square is secant square.
Mm. Mm.
Okay, fine. It's not coming. Okay, this is the better thing.
Mm.
Okay. One way to guess is
Mm.
cos plus sine is there. So if you square this one, cos square and sin square will come. Only the cross term will be there, 2 sine cos.
Mm.
Okay, only this thing will be there, 2 sine cos, and then 1 is there, and then cos square. So that way you can get that.
Mm.
And then 1 minus cos square will give me sine square.
Okay, sir.
And then I get the ratio is.
Mm.
Let me use the first one. So this one, cosecant minus
Mm.
sine, secant minus cos. So
Mm.
in maths, you have to recognize the pattern.
Mm.
So once you have something like this, something similar comes in, the method will be similar.
Mm.
Okay.
Uh,
So secant minus sine, secant minus cos, tan equal to 1. Proves it. Yeah,
mm.
we have proves one.
So
So
1 by sine minus 1 by cos.
so
Mm.
cosecant is 1 by sine, right?
Yes, sir.
Minus sine into secant is 1 by cos minus cos into
mm,
sin by cos plus cos by sin. So take or I can take,
mm,
yeah, I can simplify this one. 1 minus sin square by sin, that is cos square by
mm,
sin. The second will be sin square by cos. The third factor is sin 1 by sin
mm.
cos. Sin square plus cos square is 1. You have always sin cos.
Ah,
So this
okay,
is
sir.
equal to 1.
Equal to 1. Mm. Okay, sir.
That's what I have done.
Mm,
Okay. Here, uh, looks how to rationalize. Okay. Multiply
mm,
1 minus cos by 1 minus. Or you can do one thing, just
mm,
multiply because you know that become 1 minus cos square. And then
mm,
square. And here the terms will cancel. We have cross multiply.
mm,
Cross multiply. You get 1 minus
mm.
sin square. Okay.
Okay,
And
sir.
cross terms will go away.
Mm,
So the 2 sin.
mm,
So here you have to recognize that if you multiply, these two will become simpler. So one you multiplying is cross multiply.
mm,
Okay.
mm,
Here cosecant plus cot is P. Prove that cos theta is okay. So cosecant I can write as, I always prefer to deal with sine and cos. It'll be simple. So 1 by
ah,
sine and
sine,
cos by sine.
cos by sine.
P.
So it's,
So now we get cos theta.
mm,
So 1 plus cos by sine. Okay.
mm,
So prove means I can also take the right hand side. So
mm,
I can get e square. E square is this
mm,
square by this square. So plus 1,
mm,
so I'll get the answer. So from here, I'll
oh,
get t square as 1 plus
plus,
2 cos
uh,
plus cos square by sine square.
mm,
Okay.
mm,
And then t square minus 1.
ah,
And one more thing you can guess is cosecant minus
mm,
cot, right? So we have this relation cosecant square
mm,
minus cot square
mm,
equal to 1.
mm,
If I multiply this by cosecant minus cot,
mm,
I'll get this one. It'll be simpler.
mm,
Okay. So that's what they are done.
mm,
So multiply, so I'll get left hand side as 1 equal to p into cosecant minus cot. Okay. So 1 by p is cosecant minus cot. Okay. So here we have this one relation cosecant plus cot is p and cosecant minus cot is 1 by p.
mm,
And we have to solve for cos theta. So from here I can solve for cosecant and cot.
mm.
Now we get cos theta, right? Cos theta is very big secant theta at least. Secant theta means I'll get
Mm,
mm, The cosecant is 1 by sine, and then cot is cos by sine. So defect of cot and cosecant, I'll get cos. Once I know cos, this is what I have to find out. Cos you have to find out. Okay, so from these two relations, I know cosecant and cot. First, two variables, cosecant and cot. Here also two variables, cosecant and cot. So solving this, I can find cosecant and cot. So cosecant is 1 by secant, and cot is cos by sine. So divide these two. That is cosecant by cot by cosecant. Cot by cos. Okay, cot by cosecant we are done, which is cos. Okay, so this you have to remember. One thing, okay, recognize the pattern. So cos is nothing but cot by cosecant, because cot is cos by and
Cos by secant.
cosecant is 1 by sine. Okay, so if you know cot and cosecant, I can solve this one. I can get cosecant. The cosecant, this cot is given, and you have cosecant minus cot. So using this, I can get cosecant plus cot. Cosecant plus cot is given, so I can get cosecant minus cot. The other one. 1 by 2. So now I have two equations. So I can solve for cosecant and cot. So once I know cosecant and cot, if I take the ratio, I'll get cos. This is simple because it's sine square by cos square and sine square by this one. If I cross multiply, I get this one. Right? This sine by cos square and then sine by cos. This again, so just have to cross multiply. Right?
Okay, sir.
So this one, so this cos square, if I get sine square, then I get sine square. There will be some cross term. And here also cross EV. One will be, which is going to cancel. Yeah, it's going to cancel. So there's a minus sign here. So cross term will cancel. So you get sine term is this one. This one cos cube minus sine cube. Sine. Okay. Here also can get a hint. Cos term is sine. Okay. So this, do you know this identity a cube minus b cube equal to what? Minus b into a square plus ab plus b square. Okay. So this is third degree polynomial, right? So 1 degree has come out, so remaining this thing should be second degree. So second degree, a will be 2, and then b is 0. I mean, a will go down to 1, b will increase to 1, and here b will increase to 2, and a will decrease to 0. So here the power of a is 2, 1, 0, and b is 0, 1, 2. After the AB to be in the middle. Okay. So this, do you know this relation A raised to the power n minus b raised to the power n? So 1 degree will come out, and then a minus 1. We start with a in minus 1, b is 0, and then power of a will a in minus 2, and then b. Okay. Minus 3b square, and the last term will be b raised to the power n minus 1. A will be 0. So if you put 3, I'll get this one. Okay. So in this, if I put b equal to minus b1, I'll get this one because we make it plus.
Mm.
And b, if you put minus 2, I'll get this plus. Means b
Okay, sir.
will become minus b1, and we'll get this minus.
Mm.
Standard identity. Have you studied this
Mm.
one? If you don't know this,
No, sir.
you remember these two.
Mm.
Okay. This can be checked by expanding. Just expand, you'll get a cube
Mm.
minus p and this
Mm.
will get minus p cube. And the other terms will cancel.
Mm.
Okay. A with this a square will give me a cube, and with b with this b square will give me b cube. The remaining terms will cancel. Total number of terms is 2 into 3,
Mm.
6 terms. But only
Mm.
survive. The remaining 4 will cancel.
Mm.
Okay. So using that thing here, a cube minus b cube, and then a cube plus b cube. So a cube minus b cube or b cube minus a cube is you have to be
Mm.
so a minus b to second order polynomial. Okay. A cube plus b cube first order and then second order polynomial.
Mm.
Okay. So if you do that,
Mm.
number is same. Okay. Once you do that, this a minus b will cancel this one, and a plus b will cancel with this one. Only the second order will remain. Okay. So the denominator will be this one by this one. Oh, the denominator cancel. This thing will go, and this will go with this one. Okay. So only the numerator will be there. Correct.
Mm.
Okay. This is a minus b, which is this one. They have put this thing, after they will cancel. So only this second degree polynomial will be there, which is this one. Okay, here also
Ah.
this one, a plus b, and only the second order polynomial.
Okay.
And then
Ah.
cos square here, a, and then sine square,
Mm.
and this sine square and cos square will mean 1. Okay,
Mm.
cos sine, and then minus cos. Since the cos terms well, and there is a minus here.
Mm.
Okay, so actually this is 1, and here there is a 1.
Mm. Mm.
So the 1 minus 1 will go. Okay, this 2 will go. And then cos sign and the minus of cos sign will be 2 cos sign. Max, you have to practice. You have to remember you have to recognize the.
Ah.
Okay.
Okay, sir.
Here the thing is a cube minus b cube. Okay,
Mm.
this thing has to come to your mind. And then there is a minus b. So a minus b will cancel with this one. And simply a cube plus b cube divided by a plus b. So obviously this thing will go.
Okay.
After second degree sine square cos is easy to simplify. And then
Mm.
there is no ab.
Mm.
So this one
Mm.
sine by cos 1 by cos. Yeah. So you can write this as sine by 1 by sine.
Mm.
First term is sine divided by 1 by sine plus, 1 by cos. Second is 1 by cos. Tan is sine by cos minus 1. Just the first term. Okay, so this will be multiplied by cos. So sine cos by 1 plus sine minus cos. Okay, this will be exactly opposite. The second will be sine cos by 1 plus cos minus. And this you can check. Cos by sine, 1 by sine, cos by sine. Just S and sine, S and C are getting interchanged.
Mm.
S and C, I'll get this one. Okay, so to add these two, so SC will come out,
Mm.
and then I have to simplify down, take the cross product and simplify. This coming as 1 is a, so it will be SC into 1 plus this, 1 plus I'll cross multiply, I'll get 2 plus, these will cancel, sine minus this. So it will be just 2 divided by product of these two, which I have to, like, I have to get it as 1, right? So I have to expand them. Sine cos by this product. This product I can write as, this I'll write as 1 minus sine by cos. This 1 minus b square. B square is this minus c whole square. That is b square minus 2 sine cos. And this is 1, so this will cancel this 1. And this minus will make it plus. So this 2ac by 2ac. Okay.
Oneness.
First term is this one. We got it, this one, right? The first term. Sine by this one. Secant is 1 by cos. Tan is cos minus 1. Okay. So my by cos will become sine cos by 1 plus sine minus cos. This is second term is same as first term. We have to interchange cos and sine. Here it is cos instead of sine. This is 1 by cos, and this is, sorry, 1 by sine and then cos by sine. Okay, here it is opposite, other way around, right? So the second term will be interchange. So we'll get cos sine, which is same as sine cos. Instead of sine, I have cos, and second this one. Okay. Here, numerator will come out, it's common. Where cross multiply. Okay, it will become 2 sine and minus sine.
Oh, sine and minus here.
Just 2. Okay. So I can write this 1 minus cos 1 minus sine. So
Sine square.
So a square, b square, which is this square. So sine square is also minus 2 ac. Again, this is 1. I will cancel this 1. So minus 2 ac plus 2 ac, which is same as the numerator. So in the exam, you can use symbol S for sine. You don't have to write it. And if it is sine A, and there is one more angle B means you can make the difference. You can write S suffix A and S suffix B.
Okay.
S C and tan as T. And cosecant is cos. And secant
1 by cos.
And secant
1
is
by s.
1 by cosecant is, so cosecant is 1 by sine. And cot is 1 by T. These symbols I can write all the 6 ratios. And there are multiple angles for the suffix. There is B angle. Okay.
Okay, sir.
Otherwise, you'll have to keep writing. 1 plus tan square. But here, so we can get a hint. Multiply numerator and denominator by 1 plus tan. 40 tan, both left and right half. And see, even if you expand this one, I'll get 1 plus tan square. 1 plus secant square plus tan square. So the right hand side, just expand this one. I'll get 1 plus tan square, which is secant square plus cross term minus 2 tan. Denominator square, I'll get 1 plus cot square, that is cosecant square, minus 2 1 by t. Okay.
Okay, sir.
Or I can do this. Cot I can write as 1 by tan. Cot if I it is 1 minus t divided by 1 minus 1 by t. So my numerator t with t square minus 1, t minus 1. So which is t plus 1. I made some mistake.
Okay.
1 t I left out. No, t minus 1 minus t, what is 1 by t, t minus 1
Mm.
minus 1,
Mm.
that is cancelled.
Okay.
Minus, I have to square it, rest will become tan square. I have to square this square. Okay, so right hand side is tan square. So same thing I can do here, cot I can write as 1 by tan. So 1 by tan square by 1 plus 1 by t square. So it will be t square. Both are same.
Mm.
That's what he has done. So here you're reducing left hand side to one thing and reducing right hand side to one thing, and then the reduced one is same. So the original one should be same.
Mm.
This is another way of proving. One way of proving is take the left hand side, manipulate it, and show it is same as right. Another thing is you manipulate the left hand side, get something, manipulate the right hand side and get something, and see both are
Mm.
equal. Okay, correct?
Mm.
So once you see this one, obviously you should know it's a cube minus b cube. So secant cube, secant minus cos into second degree in this one.
Mm.
Okay, so that's what they have done here. A cube minus b cube, a minus b, and then second order. Okay, polynomial in this thing. So it will start with secant square, and then power of secant a will go down, and the power of the second will go up. And after that, it will be this thing will rise to 2, and this power will go to 0.
Mm.
Here, a cube minus b cube, which is a minus b, and then a square. Okay, the power
Mm.
a will go down, a square, a, and then a raised to the power 0, and then b raised to the power
Mm.
0, b, and then b square.
Mm.
Okay,
Mm.
that is one first thing you have to do. And after that, you write
Mm.
sin and cos.
Mm.
Okay, and then you can simplify. Once you get sin and cos, this also you can write in terms of sin and cos. Now it becomes algebra problem only. Okay, you try. After
Mm.
this cos, sin minus cos, numerator is same, sin cos. That will cancel this power 2. So just one sin cos will be there. And here we have one sin plus cos, there is 1. 1 plus
Mm.
cos sin e. And this one is cos minus sin.
Mm.
Cos minus sin. Where did it go? Sin minus cos.
Mm.
And this product.
Mm. So 1 plus.
Okay, this you can do. I'll leave it to you. If you're not able to do, I'll do it next time.
Okay, sir.
So P is this one and Q is this one. So obviously there is a symmetry, like sin has cos has become sin and sin has become
Mm.
okay. So here you have to prove this one.
Mm.
Okay, P square. This both get complicated. Okay, so P is this one. You can simplify first. Cos can I write as
Mm.
1. This one useful. Okay.
Mm.
So you straight away taken this big one. So P is this one. So P square is this square, and then Q square, this one, and then S3. Okay,
Mm.
under the full thing.
Mm.
And then you have to, this is cos raised to the power 4 by sin square. And then you can cross multiply. You get 6.
Mm.
Here it's correct and here also it's correct. So these things will cancel. After
Mm.
18.
Mm.
Okay.
Okay, sir.
So here it's of the form a cube, b cube, and 3ab.
Mm.
This one a cube plus b cube. A cube plus b cube is a plus b, and then second order, so be a square minus ab plus b square. Okay, because minus sign is required because only two terms have to survive. Other things have to cancel. That is because only there is a minus sign here. You can check the identity in the beginning. Okay, so
Mm.
it's fun.
Mm.
A cube plus b cube.
Mm.
We have written in a different way.
Mm.
A cube plus b cube formula.
A, ah, A minus B, A square plus B square plus A into B.
No, minus will come inside.
Mm. So, oh, okay, okay. So A plus B, A square plus B square minus AB.
What I said was one method. They are done by a different method, slightly different.
Mm. Okay, sir.
Here a cube plus b cube
Mm.
plus b. Okay, here if you call, okay, what they have is a cube
Mm.
plus b cube plus 3ab they have.
Mm.
Okay, so a plus b whole cube would not be this
Mm.
one. Okay, now
Oh.
they have written a plus b whole cube minus 3ab minus this one, and this they have kept it same. They
Mm.
used different identity. You can write a plus b
Mm.
whole cube, a cube
Mm.
plus b cube plus
Mm.
3ab
Mm. Mm.
square plus b square. Is that correct? That's what they have done. So they use
Okay.
this one for a cube plus b cube.
Mm.
This can be done. Also, the one I said a cube plus b cube
Mm.
equal to a plus b,
Mm.
the second order
Mm.
polynomial a square minus ab
Mm.
plus b square. Okay,
Mm.
this also you can do. So try this one and
Okay.
we're getting the answer. So we'll stop now.
Mm.
Okay, I think we're almost done what we planned.
The example sums.
Next is height and distances. So practice this
Mm.
question. Uh,
Mm.
you don't get anything, let me know.
Okay, sir.
Yeah. Okay then. Yeah.
Mm. Thank you, sir.
Mm.